Hello, Matt G for IYT here. Today we're looking at the full license mock examination number 1, version 1.6, and we've reached question 30, which reads, a transceiver will often share circuits between transmitter and receiver. Typically this would include the A, frequency modulator, B, discriminator, C, AGC circuits, or D, IF filters. Well, let's think about the things that would exist in both a transmitter and a receiver, both a transmitter and receiver. Well, a frequency modulator, that's going to exist in a transmitter, but it's not necessarily going to exist in a receiver, so it's not something that a receiver can make use of. You'll find one in a transceiver somewhere, but it's not shared between those two functions. A discriminator is really the opposite of what a frequency modulator is doing, so it's something that is demodulating a signal, and that's going to be present in the receiver, but it's not necessarily going to be something that the transmitter is going to be able to use, so we can scrub that one out as well. AGC circuits, auto gain control. Well, AGC is about changing the amount of gain in the IF stage based on the strength of the demodulated signal, and again that's all about, we're talking about a demodulated signal, that's all on the receive side, so again that's not something that is going to be shared between the transmitter and the receiver. So what we're left with is the IF filters. Why would the IF filters be shared between the transmitter and receiver? Well, in a super heterodyne receiver architecture, then what we find is we early on in the process of receiving a signal, we will mix it down to an intermediate frequency, and that allows us to use a very targeted, very accurate set of components such as IF amplifiers, IF filters. Everything's running at 10.7 megs. All the filters can be super accurate, and so it makes a lot of sense that if we can design our transmitter to also work at the same intermediate frequency until we need to mix up to what we want to transmit, we can in fact share those IF filters. So if you had an intermediate frequency filter on receive that selected just the bandwidth required for a single sideband, as say an upper sideband signal, it would make sense for you to use that same filter in the transmitter to filter your audio to generate perform some filtering so that your sideband signal that you intend to transmit is as clean as possible. So in a transceiver, you may find that the IF filters are going to be shared between the transmitter and receiver, because that is something that both parts of the transmitter and the receiver can make use of. Let's skip down to the answers, see if we got that right, and we can see that, of course, for 30 it is answer D. The IF filters can be shared between the transmitter and receiver functions within a transceiver. Thank you very much. I'll catch you for the next one.